Live from New York, it's Ask This Engineer who tries to fix things.
I tried, but it was broken. Hi, everybody, and welcome to another episode of Ask Engineer. We do this every single week, 8 p.m. here at Eastern Time. We're broadcasting live from downtown Manhattan. It's me, Lady Ada. With me is Mr. Lady Ada.
Yes.
We're both wearing black, and we're ready to rock out this electronics night.
The votes are in. The people have chosen. It's Ask an Engineer.
It's us.
Yeah, all right.
This is what you get.
That's all right. So on tonight's show...
I want to be like the Lady Ada, and you can be Vice Lady Ada.
Yeah, pretty much.
Like, what's on tonight's show?
You're the reckless one. I'm this
I know, you're going to keep
steady...
me solid.
Yeah. Okay. All right, you ready?
Yep.
On tonight's show, the code is TFT Feather. We'll talk about that and more. TFT Feather all the way up to 11:59 p.m. Eastern Time, 10% in the Adafruit store, except for...
Gift certificates, software, and AdaBox subscriptions.
That's right. Show and tell, people around the world showing and sharing their projects, come together, showing what they built. Pack the mailbags and stop by. Hi, reading some mail. Time travel, look back in the world of makers, hackers, artists, engineers, and stuff we did. Some made in New York City. We make stuff here and we take videos of it. Nimbus, friendly cloud entity, is going to deliver some amazing news about Adafruit.io. 3D printing, Raspberry Pi, new products. We'll answer your questions. We'll have a top secret thing. We'll have a trivia question. All that and more on Ask an Engineer. Okay. All right. So for the folks that saw that video when we started, we went to the Google pop-up store. I think it's called Made by Google, and it's all their home IoT stuff. And we went there, and they had lots of interesting, like we like the installation side. So there's this big ball, and it had like. Not a Raspberry Pi, but looked like one. And then we, played around with their stuff. We did some virtual reality things, and then we said, "Okay, Google," and we asked questions. And anyways, it's in Soho, and we have to see it. It's not this. I thought it would be where the Samsung pop-up store is, but that's not there anymore. It's down the street.
Yeah, well, it was a what was it before? It was a Skechers.
No, I think it was the Ben Sherman store, maybe?
Ben Sherman store,
but anyways,
yeah.
it's that time of year in New York where
Pop-up
all
store.
the giant tech companies have a pop-up store, a brand experience. So we checked it out.
There's apparently a pop-up store for the Snapchat goggles too, right?
Oh, we should go see that.
We should go see that.
Okay.
I don't think it's open yet, but we see the ads everywhere.
If we go, we'll take photos, and if there's a broken installation, you will try to fix it.
Well, I thought maybe it was stuck, so I just gave it a little bit of help. But it turns out the server was broken.
Okay. Don't forget, TFT Feather. That's what supports this show. The completely independent, supported by you, weekly show called Ask an Engineer. All right, Lady Ada, some things. This is Ask an Engineer, 8 p.m. every Wednesday. Show and tell, we just did. 7:30 p.m. Eastern time. UPS ground is free if you order $200 or more, and that's real, reliable UPS shipping. Shows up tracking all that stuff. In New York, we have same day. Check out before 11 a.m. If you're in Manhattan, it'll have some zip codes, and you'll be able to see if you can get same day. Pay attention to the holiday shipping deadlines coming up pretty soon. One little note, Friday is Veterans Day, and check out our site. We have some shipping information. We also, of course, do free shipping to military and FPO addresses.
Yes,
yeah.
If it's an address that is...
if it shows up as a...
Basically, if it's considered a military address, whether it is in the United States or in a base abroad, but basically if you can get USPS priority mail, that's what it is.
I like our little LED flag. Okay.
Yes.
All right, show and tell. Every week, people show the things important to them.
I wrote them down
to us.
on this
Lady
piece of
Ada,
paper.
what and who was on the show and tell?
Okay, we had a plethora of people, starting off with Tony D from Adafruit Northwest. Just attended SuperCon, the Hackaday I/O conference. Had some good reports. It was fun. There's a lot of cool stuff going on there. And then had a MicroPython scroller demo that he showed off and did a presentation on, but also did a video yesterday about it, basically using our LED FeatherWing with MicroPython and the SAMD Feather. Again, all sorts of cool MicroPython stuff coming from Tony D. So check out Tony D's desk videos
and
for more and more.
Scott wasn't on the show, but Scott's working on the firmware, and you'll be able to play around with a lot of interesting stuff. Look at our GitHub, Adafruit MicroPython. And
we are doing pushes every day.
Yeah, you'll be able to play along with this fun experimental phase of kind of building this new world together.
It's new.
So,
It's real new.
yeah, all right.
It's really new.
What's next?
Next up is Noah and Pedro. They showed off their Stormflower Neopix cosplay gun. It's from it's a prop from an anime called Ruby, which I've never seen. But they had a little clip of it in the video, and we'll show that as well. It's a really beautiful cosplay prop, and just showed some simple code that you can use to add NeoPixels, get them blinking. Next up, we had John Park just showed off some photos of the NeoPixel light painter that he worked on.
Yeah.
It's basically using the NeoPixel lights and then twisting them to get different colors, and you can have different light effects.
And I finally got to share my collection of Picasso photos that Picasso did. He did some light paintings a long time ago, and it's neat to share. And Picasso was really ahead of his time in all sorts of ways, but we did our version of it, so check that out.
Yeah, check that out. That's a guided video we will show as well. Chris Young came by to visit, showed off a Cubs hat that he worked on for his nephew, 11 years old, has only known a world where the Cubs win the World Series. This hat has a NeoPixel ring with a C above it, so it's a glowing C, and then on the brim there is a NeoPixel strip. So it is really cool, the coolest hat an 11-year-old could get, and he's going to show this video to that person, and that person will have an awesome hat that I'm very jealous of. A NeoPixel and feather BLE, so you can change the colors and effects from the phone.
Yeah, and the next time the Cubs win, it'll be a holographic hat or something like that.
You never know, could be next year.
They could win every year.
Doesn't have to be 108 years from now. Okay, and then Aiden is playing around with different actuator shapes, including one made out of Ninja Flex, a sphere with cylinders cut out that when you twist it has a 5-to-1 compression ratio. So kind of thinking, what kind of soft robotics actuators can you use? Because most actuators, he's shown the inflatable ones, they only go maybe 10%.
Yeah.
This one expands and contracts by quite a bit using twisting motion, so it's not even hydraulic.
Looked like a ship from Babylon 5.
Okay.
Anyways, yeah.
He also showed off some old actuators as well, and then trying to make a triple actuator, not quite working yet. Richard A. Is trying out a library for the ESP8266 Arduino core called Wi-Fi Manager that helps you basically create projects that you don't have to hard code the SSID, and what it'll do if it can't connect to the internet, it'll show up as an access point that you can then connect to, and has a nice graphical interface to type in the Wi-Fi password. You see, basically every IoT device we have, you got to do the same thing.
Yeah, big challenge for IoT devices is getting it on networks. This is something that we play with all sorts of consumer electronics, and you set up your phone and you have to find it makes it a little access point, drop canvas, all sorts of interesting things that is a challenge right now. Bluetooth Low Energy is kind of neat. There's lots of interesting ways you can do stuff, but anyways.
Dude, it is hard. There was buttons that you could press, but that never caught on. Okay, so that was Richard A, and he's maybe going to make a tutorial about that, so it'll be neat. Andrew C, I guess it's only been a week since Halloween, showed up with a post-Halloween project, a pumpkin face. It's like a pumpkin with LED matrices, and it's similar to a project that Phil B did a while ago. He ported it to the ESP8266 and wrote the code in JavaScript, and even made a little tool so you can create custom animations for your pumpkin face. So I think he'll post that up and people can use it. Very handy for, you have an 8x8 grid, you want to make little animations. How do you do that?
And one thing that I thought was neat, when he was building this, he said, I couldn't find some Arduino code, so I just did it in JavaScript. So we're in an interesting new world where the programming choices are increasing for microcontrollers.
We are in a post-Arduino society.
Yeah.
It used to be just Arduino, now it's Arduino, JavaScript, MicroPython.
Yeah, Span.
Lua, Spin,
all sorts of choices.
Blockly.
Yeah.
Many options.
Yep.
It's like the what's that time when the Earth Moon was there were lots of species?
Precambrian.
It's like the Precambrian explosion.
Yeah.
Too much oxygen in the air.
Yeah.
And last but not least, C. Scott showed off the Undertale cosplay costume that his son made for Halloween. It's this big head, and he kind of talked about what I like about C. Scott's talks is he's an engineer. He clearly knows his analog, knows his digital, does layout, not scared to design a CPU emulator if necessary. But in this case, he's like, hey, I just went to Walmart or Target, remember, and he got these little LED lights that just had a coin cell and LED, very simple little mechanism, very low cost, and just put that into the mask rather than trying to engineer something. Like, totally could have engineered something, but it's like, you know what? Actually, the best option is just to take these little LED, not candles, but they're fake candles, and you stick them into this mask, and it creates the effect he wants with the eyes.
Good engineering. Sometimes you buy, sometimes you build, sometimes you do a little bit of each.
Okay.
All right. So that was the show and tell this week. All
it was
participants
amazing.
On the show and tell get an Ask Gene on the show and tell sticker. Email support@adafruit.com, and we'll send you on. It's part of our Adafruit live series that we do every week. This week we had a desk of Lady Ada. We did like a desk of Phil this morning, just showing some of the testing that we do with some of the things from home for some of these new platforms. John Park this week has a very fun circuit playground video, as you had mentioned, light painting and more. I like when he gets into the camera mode and he's like,
"This he's kind of dark and
yeah,
gothy.
He's like, hey,
hey."
So take it away, JP.
What am I doing, you might ask? Good question. This. Hi, this is John Park for Adafruit, and today I'd like to show you how to build your own Circuit Playground light paintbrush. A light paintbrush is used during long exposure photography to create streaks of colored light. Now, the Circuit Playground has neopixels, which can be pretty much any color we want, and it has an accelerometer that we can use to change that color based on tilt. What I've done is taken a battery pack, the Circuit Playground, some alligator clips, and a potentiometer just to adjust the brightness. I've put these together and written a small piece of software that changes the color based on the tilt. Let me show you how to put your own together. You'll start off with some alligator clips. You'll need 3 of them. What I did was cut the ends off and then used wire strippers to strip off a little bit of the insulation. What I'm going to do with these is solder them to the potentiometer. Now, you could use the alligator clip as advertised and just clip onto each end, and maybe use some tape to keep them secure, but I decided to go that extra little step and solder these on. You can follow the circuit diagram in the learning guide. What we're going to do is connect ground to the left pin on the potentiometer, voltage on the right, and the control signal is going to be that yellow wire in the middle. What you want to do is tin each of these legs on the potentiometer with your soldering iron and tin the wires, then heat them up and stick them together. You can even use a little piece of heat shrink tubing if you want to be extra careful. Okay, the potentiometer is wired up, and now what we're going to do is connect that to the Circuit Playground. So the black clip will go to one of the ground holes on the Circuit Playground, red to a 3.3 volt, and we're going to use pin 10 for this signal, the yellow wire. Okay, now when you upload your code, the neopixels will dim or brighten based on the signal coming from the potentiometer. The next step is to attach the battery pack to the Circuit Playground, which will A, power the Circuit Playground, and B, give us a little handle to hold it. So what we'll do is trim off a little piece of foam double stick tape and attach that to the back of the Circuit Playground. And now we can attach the battery pack to the foam tape. Just like that. Plug in your wire, and now we've got power. And the last thing we're going to do is connect the potentiometer also with some foam tape to the top so that we have a nice, neat package. And now with the software uploaded to the Circuit Playground light paintbrush, we can adjust the brightness, check our tilt, and then it's time to turn off the lights, set your camera to a long exposure, and try creating some interesting and beautiful patterns in light. For Adafruit, I'm John Park. Be sure to check out the guide for all the information on building the Circuit Playground light paintbrush.
John Park quickly becoming the Jackson Pollock of LED painting. Okay, desk of Tony D. back in the swing of things, MicroPython hardware LED packbacks and FeatherWings, MicroPython hardware Charlie Plex LED matrix. That's a neat one if you wanted to do some text scrolling and more, and then the text scroller memory optimization. That's one of the ones I'm going to try tonight.
Okay.
So, what I like is the idea that anyone could plug in one of our boards, edit a text file, and they got a badge. That simple. They plug it in, shows up a USB drive, double click a file, edit text, and now they're good to go. And then they can explore more. So we like the idea of like a very easy conference badge and all that, because I've been to many conferences and it's like, okay, if you want to do anything, it's an ordeal. This is something that can get anyone started, and that's a good thing, because if you're at a conference, Ask an Engineer started because we got a free web camera.
That's right.
So you never know what's going to happen. All right, so we still haven't found a name for this little cute MicroPython snake. If anyone, someone suggested Pippa. That's kind of in the running right now.
Okay.
And
I like Pippa.
Yeah, Pippa. You know, this is based on the little thing here. And I've got some microbits at home, and
Yeah,
I'm playing
you
around
got
with
some.
them. Yeah, playing around
Thanks,
with them.
Pimroni.
We took some photos. They're not available really in the U.S., so we ordered them from Pimroni. We're playing around with it. It's neat because there's a little blockly interface, and it's very Scratch-like. Okay. Anyways, that's what's going on
Things
this
are
week.
happening.
Mailbag. Unpack it. We read these emails to everyone every week at State of the Fruit, our weekly all-company meeting, and we also
Are
read
these
them to you.
faked? Are they real?
No.
Do people really send us letters like this?
If you look inside of our blog, you can see the scheduled mailbags we have all the way up to like 2030.
Wow, people are so nice.
Living on Mars, going to be seeing these.
Okay.
Okay. So this week's is from Mark. Hi guys, just received a replacement PCB and ZIF socket in the mail. Thank you so much. I wasn't expecting a free replacement since I made a soldering mistake. I really appreciate what you did. It's not often you come across great customer service. I love the site so much that my partner has also placed an order with you to be delivered to me. I can assure you we'll be customers for a long time. Many thanks and have a great day. Best regards, Mark. Thanks,
What
Mark.
a nice mark.
That's a nice one. Okay. Time travel. We look back in the world of hackers, makers, artists, engineers, events on our site, all sorts of things.
What has happened in the past?
Well, this month we're celebrating Native American Heritage Month 2016. You know, I did the one of the 23andMe tests is a little bit of a Native American.
Really?
Yeah, a little bit.
That's interesting.
A little bit, yeah. Like,
I wonder what mine was. I don't remember.
we can log in and look at
Yeah,
it.
we should look.
We can export your genetic code and use that Prometheus site, and I can get it. I can have your DNA code. We should make more Lady Adas.
I'm surprised nobody's been like, you should totally put your DNA in the blockchain. 'Cause that's a terrible idea.
I think that was a plot line to the new Superman series.
Yeah.
Anyways, okay, so a couple posts from the blog. Here's the first one. Susan was an Omaha Indian doctor, and she's known as the first, I think, Native American physician. She campaigned for public health and for formal legal and allotment of land members to the Omaha tribe. Interesting, there's always a lot of firsts. Sometimes there's firsts, and sometimes there isn't. This is the first. So check her out.
Okay, cool.
Yeah, we also.
She looks serious. I like
she's
her.
super serious.
Look
And
at
then
this.
this is always an interesting story that comes in. And during World War II, we were trying to have codes and everything that the enemies couldn't crack.
The Axis.
Yeah, and they used this language, and this was the Code Talkers.
So the Choctaw Code
yeah.
Talkers. So there's actually
Oh no, sorry. This is World War One. Yeah.
This is World War, okay, so, but in
yeah.
World War II with the Navajo Code
Yeah.
Talkers, but World War I
Yeah.
were the Choctaw
Yeah,
Code
so that's a
Talkers.
really interesting thing, using an ancient language that there's no way that anyone has reference
It's
there.
completely native language.
Yeah, that's kind of like security through obscurity almost.
It
Like, it's
is,
kinda neat.
it is, but you know, if you're gonna, what if you have to send things fast and they only have to be secret for a little bit?
Yeah.
Maybe it's okay.
And then this is kind of fun history. That's not a Native American Heritage Month history, just from our site and blog. 2012, we released the new Arduino Micro in collaboration with Arduino. So it was the Adafruit Arduino.
That was only 4 years ago, wow.
It seems like an eternity.
It seems like 8
A
years
simpler
ago
time.
It was
A kinder, gentler time. Okay.
Okay.
So that was.
And now we're making them.
And now we're making them. And also, we went to a first event last week.
Well, this is actually like that time, that logo that you have.
Yeah,
for
this.
the time
This
travel.
This
is it.
Dean came and was at this. It was a fundraiser for FIRST, and it was some other things going on there. But it's a clock that goes like 2 steps forward, 2 steps back. And
Yeah,
tick, tick,
for
tick.
every minute it goes twice. It goes twice, 3 times as fast forward, and then 1/3 is fast back. So like every minute, it goes forward like 20 seconds and then back 10 seconds, forward 20 seconds, back 10 seconds. It kind of zigzags.
Yeah.
And it's a metaphor.
It's a metaphor for something.
That's what he said.
And then you did it. You met some of the students that had their projects there.
It was
and
so
the
much
robots.
fun.
Yeah.
I got to drive a robot.
Yeah, and
it was a bad idea.
And what was neat, because we're doing a lot of research and communications with schools and more, and seeing what they use and what they do. Adafruit is used quite a bit, and the code that like Phil B wrote for NeoPixels, we saw it everywhere. And you also got the controller robot. So let's check it out.
People didn't die.
Well,
barely.
Yeah.
So what we have right here, over here I have control of the software. So I can So now you got to try to pick that one up.
I have a question. Is it like you pick it up like scoop it under or scoop it above?
Or scoop it under. So
Really?
when we pick it up, you want to use that middle position. Like that.
Ah, that's the roller. Got it.
Now you got it.
Okay. You have to.
So, good work, Lady Ada, holding a drink and running a robot. I think that's the definition of
Don't
success.
drink and drive robots. Actually, only drink and drive robots because that's the most fun you can have.
And special thanks to the Standard General folks in Radio Shack who invited us to get. We've never been to an event like that. It was a gala.
It was a gala.
We got dressed up. And then earlier in the day, which was really neat, you were a participant in the CS for All New York City Department of Education efforts, and this was an animal rescue hackathon. And this were all the kids that came up with ideas to help save animals, and they were using programming in Scratch. And then they were presenting their ideas. You were one of the judges. You helped some of the kids code. And so these are just some of the photos, and then I have a quick video.
Hey lady, what is this?
Hey, we're at the CS4NY hackathon where all of these awesome kids are working on making pro-animal conservation PSAs, and I'm going to be helping judge some of these Scratch projects and seeing what creativity they're up to.
Yeah, they're using Scratch, and it's mostly on Mac. We always like to see what schools are using, so they have Laser Etch Department of NYC Education laptops all around here. So that's really neat. Okay. And they're building the little programs and more. So, okay, so you're going to be chatting with all these kids and work with them to figure out how they can help the animals.
Okay.
A couple hundred kids, ain't no thing. That was a lot of fun.
They totally just fed them like pizza and
Yeah.
like soft drinks with caffeine and let them write code for a couple hours. It was crazy.
Open source hardware news, congratulations. All the team members here and around the world that work with Adafruit, and thank you to all our customers and community. Adafruit was recognized as a 2016 Fast 50 company by Cranes, and you're in here, you're number 25 out of 50, and this was all about growth, so we're growing very fast. Yeah, it's a very sharp trophy there, and thank you everyone. We're not funded. We're not. We don't have any loans or anything.
No.
But
no tax breaks for us.
We did publish our numbers, and we submitted, and we're a top 50 company. 29 out of all companies, and I think in the top 10 for woman-owned companies. So, thank you everyone. Very cool.
Thank you. This
is neat.
Very plasticky and lovely.
Yeah.
We will underlight it with some LEDs.
And here's the thing.
What?
We don't hear this as much anymore, but a lot of people say, well, you're open source, you give everything away. How could you possibly be a company? And you know, the numbers are there. It makes sense.
Yep.
It doesn't make sense for everyone, but how do you know if you try?
You know what, though? I like playing on hard mode, so
Yeah.
having
All
to
right.
do everything open source, make it a little more challenging, why not?
Speaking of open source hardware, we're a member of the Open Source Hardware Association. Guess what came out? Michael Weinberg posted this up. It's the Open Source Hardware Certification IDs. They're
Yay!
live. There's about 60 different projects right now in 9 different countries. We're going to have some of our stuff in there. You can
Wait,
go,
so that means if there's 60 projects, that means number 69 is still available.
it might be, but
Okay,
also,
everybody, submit
but-
your project immediately.
But no, we want to try to get 666 is a fun thing to do. And then we want to point people to the Open Source Hardware certificate. You self-certify. You can see a list of all the projects. Props
Okay,
to
let's
everyone.
get something on there.
Yeah, props to everyone out there who's doing this. Neat projects. I remember when I used to write my open source gift guide, and there was only 4 things. Then there was like 400. Now there's 4,000. Now there's
It used to be you could have a gift guide with all open source, all the things that were open source hardware.
yeah.
For that
Get
year.
a Chumby. Get a maker hacker
It was like
board.
one Arduino and
Yeah.
then like an MP3 player that you solder yourself
Yeah.
and Chumby.
Yeah. So next up, Adafruit Learning System. We have
We had some good
yeah
good projects.
1,099 guides this week. Lady,
Really? Are we up to 1,099?
Yeah.
Ooh, I gotta release one more guide, huh?
Yeah.
Okay, maybe I'll
Yeah,
go home and roll out.
what's
Well,
going
there's
on?
a couple that are
Yeah.
still pending. Okay, I don't remember precisely which from last week, but I'll just read only those 4.
Yeah,
If not
this one, and then
bottom?
we have one more after that.
The glowing LED chair was from last week's 3D Hangout, so that's live. That was from last week. How Cold Is It was a tutorial project by Carter Nelson with the Circuit Playground that it's kind of neat. It uses the temperature sensor and displays the temperature on the LEDs using binary notation, so check that out. MicroPython hardware, DC motor and stepper driver. That was a Tony D guide where he made a little mini robot using, I think, the ESP feather, and then used the web REPL to control it. And then LED backpacks and FeatherWings, I think that was, and then the LED CharliePlex LED matrix. So basically, we're going through all of the FeatherWings, and the reason we're doing that is not just because the ESP8266 and the SAMD run MicroPython, but because most of the most popular chipsets that we use are on FeatherWing. So if we cover those, we've covered like 90% of what people
Okay.
like.
And then you just
wait,
this
no,
guide.
I didn't finish.
Oh, you want to do more?
Yeah, and then the NeoAnim guide. So that's a guide from Phil B. and John Park, and that's actually from a previous guide, but they wanted to show like how you can take a graphics file and use that as a way to animate NeoPixels. So it's actually kind of a neat idea, and of course you can generalize it to NeoPixel rings in general, but I like this because it solves a common problem. People are like, I want it to look like a candy stripe or something, and they can draw it, but then how do they program it? This it kind of does it for you. And then the Mac address finder, which was a person who showed up on the show and tell 2 weeks ago, and I was like so into the project, I said, hey, could you please write it up? It's a little ESP H66 feather and an OLED FeatherWing that creates an access point that when you connect to it, it tells you the MAC address of the thing that connected, which is really handy when you're trying to find the MAC address of like your Xbox, something that isn't easy to find at the MAC address. And then 3D Hangouts, this week's project, the Lee ran. Stormflower showed the video of that. And then this is the tutorial for this week's new product, the TFT FeatherWing.
Yeah. Okay. So that's what we got going in Adafruit Learning System. Learn.adafruit.com. One of the most fun places on the internet. You just go there and you can see all the fun stuff that you can build. That's what we do. Okay.
Wow, we're so close to 1,100.
In New York City, we make stuff here.
Do we?
We do.
For reals?
We do. And then we do these little Instagram videos, time lapse, and we just like to show some of the things that go into the stuff we make.
These are the parts that I think that, they drop from the pick and place.
Yeah.
So they go into a bin, and then we're like, we can use them for photos and stuff. So you can see SIM card holders, video cards.
This is a rework video where we're putting on this little chip. Beep, beep. Solder it up.
You can do it.
It's a little soundboard.
Yeah, sometimes the audio jacks, I don't know why. It is actually something, I've noticed that some connectors we have, they're floaty.
They're fussy.
They're fussy and they're floaty, and I don't know why. And sometimes when I contact the manufacturer and say, hey, can we get a version that isn't floaty? They'll be like, oh yeah, we have a version that's not floaty. And I'm like, what is the technical term for this? But sometimes they don't wet into the Rojas solder paste that we have.
Yeah.
And so they float above and then they come off.
On DigiKey, can you do a checkbox that says non-floaty?
I do not, what better wetting, but we had the issue with the SIM card holders and we solved it actually. We went back to the manufacturer and said, hey, we'll pay a little bit more if you solve this problem, and they did, and I have no idea what they did.
Okay. Less floaty.
We all floaty
Get floaty
down
older
here.
On the side. Here is Nimbus, the friendly cloud entity. And Nimbus is here to tell you all sorts of good things about Adafruit.io. Adafruit.io is our free beta service for makers. Adafruit.io, you can do cool things like dashboards and buzzers and bells, and we have an update. Congratulations, Adafruit.io team. We now have over 18,000 users, and we have 13,000 online feeds. The 18,000 users were up almost 10% month over month growth on Adafruit IO. So if you want to join in on the IoT revolution, this is a way to do it.
Oh,
Yeah, so we got that going on.
that's cool.
All right, good work, everyone. 3D
77
printing.
inserts per second. That's pretty good. That's up.
Yep. So 3D printing, Noah and Pedro are doing neat projects every single week that I think shows that 3D printing is more than, oh, look, it's 3D printing. It's actually stuff you can do, fun things, it's enclosures, it's adding electronics. And I think when folks get a 3D printer, if they don't have cool projects to do, it kind of just sits there. You can only print the green Yoda head so many times. So here is a guide and a video. No, Pedro.
Hey, what's up guys? Noah here for Adafruit. This week, I got a really cool cosplay prop for you. This is Lyran's Stormflower from the anime web series RWBY, and in the front of the barrel I have a NeoPixel, and behind the trigger I have a push button, so when I squeeze the trigger, I get this really nice NeoPixel animation. Inside the magazine, I actually have an Adafruit trinket and a 500 milliamp LiPo battery. It's a really good spot for the electronics. Of course, this entire prop is 3D printed. So in this project video, I want to share with you guys how you can adapt the circuit and Arduino code for your cosplay props. So, let's get started. So the electronics I use in this project are great for cosplay weapons, or really anything that needs to flash when you press a button. For this project, we'll use an Adafruit trinket, a NeoPixel, a push button, JST breakout, and battery. The NeoPixel needs 3 connections for power, ground, and data. The push button will be tied to ground and a second pin on the Adafruit trinket. The battery plugs into the JST breakout, and the power and ground will connect to the Adafruit trinket. In the Arduino sketch, we'll import the NeoPixel library, define the pins and number of pixels. We'll also create the NeoPixel object. In the setup, we'll initiate the NeoPixel and set the button pin as a pull-up input. Then in the loop, we'll say if the button is set low, then run the animation function. Otherwise, turn off the NeoPixel. The animation function itself uses linear interpolation to fade RGB color values in a gradient over a period of time. It's easy to change the colors in the gradient, and you can also scale the animation by increasing the number of pixels. Be sure to check out the tutorial to get the full code and a better understanding of how it all works. I designed the Stormflower in Fusion 360. I built the prop using components and made sure to create channels so that I could run the wires through the various parts. I also separated them into pieces so that I wouldn't need any support material when 3D printing. I 3D printed all of the pieces on a Sigma 3D printer from BCN 3D. There's a total of 24 pieces, which sounds like a lot of 3D printing, but it definitely wasn't enough to burn through a whole spool. I used a 20% infill for all of the parts, and I probably only used about 10% of the spool. I heated the glass bed up to 65°, and I was extruding at around 220°, which is a bit hot, but that helps keep the flow consistent. It's also worth noting that I used 1.75 filament, which works really well on the Sigma 3D printer, even though it's only supposed to run 2.85 filament. So here's all of the pieces. I didn't do any post-processing, but you definitely could sand them down if you want a really smooth finish. I started by gluing the main pieces of the blade together using E6000, which is a silicone-based adhesive. Then I glued the middle piece of the blade onto the main base of the blade. I made sure to use clamps to hold the pieces together, and I let the E6000 cure for about an hour. Then I did a quick dry fit and measured wires for the NeoPixel. I'll need 3 wires to connect to the NeoPixel. These will be for power, data, and ground. I connected these wires to the 3 pads on the bottom of the NeoPixel. Then I added some pieces of heat shrink tubing to the wires just to keep them bundled together. Next, I can get started on wiring up the Adafruit trinket. On the bottom of the board are 2 pads for power and ground. I tinned those up and connected 2 wires. Then I soldered the power connection from the trinket to the SW pin on the JST breakout, and then ground to ground. Now I can plug in the LiPo battery and flip the switch to test out the circuit. Now onto the button, I fitted it into the handle so that I can measure the lengths of wires that I'll need. I only need 2 wires, 1 for each leg. Then I'll tin them up and solder them to the button. Once again, I used heat shrink tubing to keep the wires together. Now with the button and the NeoPixel wired up, I can connect them to the trinket. I tied the ground wires from the button and the NeoPixel together and fitted them into the ground pin on the trinket and soldered them in place. Then connected the second wire from the button to pin number 2 on the trinket. For the NeoPixel, the wire for power will go into the battery pin. And the last connection is the data from the NeoPixel, which will go into pin number 0 on the trinket. With all the connections wired up, I can do a final test of the circuit to make sure everything is working. After that, I can start mounting all the pieces together. I'll start by inserting the NeoPixel through the channel in the back of the barrel and out the other end. Then I'll thread it through the front barrel piece and pull the NeoPixel through. Once it's out the other end, I can connect both of the barrel pieces together. Now I can mount the NeoPixel to the face of the barrel by pressing it in until it clicks into place. Now I can gather the main pieces together, like the handle, the trigger guard, and trigger. The keys from the trigger will fit into the slots on the trigger guard, and the keys from the guard will go into the handle. The push button then fits into the channel behind the trigger. I fitted the wires into the channel and placed the second half of the handle on top and fastened some machine screws to secure the pieces together. Now I can fit the barrel pieces onto the handles. Each piece has a key in a slot, so I'll just press the pieces together until they click into place. The Adafruit trinket, JST breakout, and battery all fit inside of the magazine, so I carefully slid them in and inserted the magazine into the bottom of the handle. Then I just need to make sure that the trigger can actuate the push button. Last thing to do is to fit the blade into the front of the barrel. The key from the blade goes into the trigger guard, and the blade itself fits underneath the barrel. And that's it for the build. I think this is a really awesome way to get triggered lighting effects, especially for cosplay props. But this would also work really well for all sorts of costumes.
So I hope you check out the tutorial for this project. Remember, it is linked down below. I also hope this inspires you to start thinking about electronics for your cosplay props, because it really adds that extra dimension. Thank you guys so much for watching. Don't forget to subscribe for more projects every week. But until then, I'll see you next time.
Oh, but wait, there's more. You want to see a time lapse, don't you?
Yes, I do.
You're like, I want to see a time lapse.
Time lapse, yeah.
I don't want to sit and wait for something to I just want to.
No, I just want all the glory without the waiting.
Yep.
So the electronics I used in this project are great for cosplay weapons, or really anything that needs to flash when you press a button. I designed the Stormflower in Fusion 360. I also separated them into pieces so that I wouldn't need any support material when 3D printing. I 3D printed all of the pieces on a Sigma 3D printer from BCN 3D. So here's all of the pieces. I didn't do any post-processing, but you definitely could sand them down if you want a really smooth finish. With all the connections wired up, I can do a final test of the circuit to make sure everything is working. After that, I can start mounting all the pieces together. I think this is a really awesome way to get triggered lighting effects, especially for cosplay props. But this would also work really well for all sorts of costumes.
Okay, I want to...
Yeah, you're thinking that was a time lapse, but I tricked you.
Yeah, that's okay.
That's okay.
Usually we have like 2 or 3 time lapses, so you know what?
Yeah.
You get a pass.
Yeah. Well, you know what? You can never see too many cosplay NeoPixel projects.
Yes.
That's my belief.
I think it was fine.
It's a core belief.
It was lovely.
All right. So tune in tomorrow at 3D Hangouts with Noah and Pedro. Every Thursday we do this. It's almost that time, Lydia. Do you know what time it is? What? Wait. Hold it. Stay on target. TFT Feather is the code, 10% off in the Adafruit store. Okay, now you do it.
No.
All right.
They didn't see me shake my hand.
Yeah. Okay. Wires.
Well, then going really in.
Other views of wires.
Go deep. Enhance. This is a sensor, and this is a new type of sensor. This is an RTD. This is a resistive temperature sensor. And it's a special kind of sensor for people who usually do high temperature sensing. Usually you're going to go with a thermocouple, and we have K-type thermocouples in the store and multiple thermocouple amplifiers that you can use. But if you want to have something more precise and accurate, Those are two different things. Thermocouples, they're neither very precise nor accurate. They're usually off by a couple degrees. They need to be calibrated, and then your precision isn't going to be much better than a couple of degrees. In comparison, this type of sensor, which is a platinum 100 ohm sensor, is a very precise, very accurate. This is almost like the standard method of measuring temperatures when you need high precision and high accuracy. Inside this sensor is a little strip of platinum that is exactly 100.0 ohms, 0.00 ohms, I think, in exactly 0 degrees centigrade. So it is a very well-calibrated resistor, and the resistance changes with temperature, and there's multiple algorithms that you can use to, it's not linear, but it's very easy to use that resistance change to convert that to a temperature change. And so it's good for large ranges of temperatures because it's mostly linear. This particular jacketing is good for up to 550 degrees C. It can go negative. There's no inherent reason you can't go in wide temperature range because you're dealing with just a resistance that changes. As long as you can measure that resistance, about a meter away, you can have a good resistance meter. You can measure temperature changes. Okay. And this is a sensor that it's a class A sensor, so it's like, I think at least 1% or better. I can't remember off the top of my head what class A is. It's either 1% or 0.1%. And it comes with 3 prongs. And the reason it comes with 3 prongs is kind of an interesting reason. Most thermistors, which is a type of thermistor, most thermistors only have 2 connections, one for either side of the resistor, and you basically put a current through it and then measure the voltage difference. That's pretty much how it works. However, when you're dealing with something that's so precise and has such small changes, 1 or half an ohm resistance can be measured, you want to make sure that the wire itself isn't part of that measurement, especially since you might be putting quite a bit of current in to make a nice large voltage. So what you do is you have a third wire and you force the current through 2 wires. I think the 2 red wires are the forcing current ones. You measure it, whichever one's 100 ohms. And then the third wire, what you do is you measure the voltage across those 2 red forcing wires and across one of the red wires and the sense wire, the blue wire. And then that will tell you the voltage difference of one wire. And then you multiply that by 2 and you subtract it. Okay. So basically it's accounting for the difference between the wire resistances, which can add up when you're doing, again, this precision sensing. We'll have an amplifier that does all this in about a week or so. Okay. We didn't get that in the store this week, but it's coming soon. We want to get this in the store now. So if you're like, oh, but I need an amplifier, hold off. We'll get you an amplifier as well. But this is a really nice sensor for people who want to do scientific research where you want to have very good repeatability, accuracy, and precision. This is pretty. It's good as it's going to get for the amount of money that you're putting in. And of course, you can always get more precise. But for about $15, this is like an excellent temperature sensor. It's a nice stainless steel tip as well. Great for those uses when a thermocouple is not precise enough, but you want more range than our precision I2C sensors, which of course can't go beyond 100 degrees C.
That was an excellent explanation. Where can you even listen to things like this live on the internet? Only
on this show. The only thing is I can't remember if it's the 2 red wires or which one is which. Maybe check the product page because it's one or the other. Or
of course 5 chat rooms, they're on it.
I'm sure well, you can measure the resistance with your multimeter. And again, the forcing wire and the sense wire, it's the same wire. It's just that you remove that delta. Sometimes you can get sensors with 4 wires. Honestly, it's not going to be different than 2 times 1 wire. You know what I mean? You'd have 2 force and 2 sense. But in my opinion, it's like if all of your wires are the same gauge and length, you're not going to gain anything by having another wire, which is basically a duplicate of the third one. So I'm a 3-wire kind of girl. Okay. But if people demand it, we'll carry a 4-wire version.
Okay. All right. This is make do. Sometimes you just got to make do.
This is kind of interesting. I actually didn't put this in the store, but I think you did, and I think you like this. This is a cardboard construction kit. And check the videos on the site. Basically, it's these really large screws and they have a big teeth. See the big tooth on it? And it's good for corrugated cardboard. And there's a little, like a cardboard saw and then a wrench that helps you attach these in. So basically the idea is you can get all this recycled cardboard from the trash, all those Amazon Prime boxes you've got, you cut them up and you can draw on them and you can shape them into robots or puppets or maybe toys or maybe a little house that you can live in.
When I was a kid, that's all I built tons and tons of cardboard structures, and then I would run strings around everywhere, and I was the only one who could get through it.
Yeah, you know what is like the most fun toy in the world? It's not like a PlayStation, it's not an Xbox, it's not an iPad. It's those refrigerator boxes.
Too, yeah.
Refrigerator boxes are amazing when you're a kid because you're like, this is enormous.
Yeah,
and they're like really rugged. You can cut them and decorate them. So this would be a tool you could use if you wanted to like construct something with that cardboard. And you get a bunch of them and then it's kind of like a fun way to, I mean, you can kind of get by with fasteners, like stud fasteners, but they're not as nice and reusable as these.
Okay. Now, sort of big news for the folks who didn't get an AdaBox subscription. We have it in the store. The only difference is it doesn't come with a pin, and this is just AdaBox just to get you going on the Feather ecosystem. So do check out the product page. We asked what folks wanted after we launched the AdaBox subscription service, and many of them said, I want to be able to get that one from the past. So we have that available now.
Yep, it doesn't have as many of the extras or bonuses and the free shipping. This is why you want to subscribe, right? If you subscribe, you get all of these extra goodies.
This is intro in the Feather world.
But maybe you missed it. Maybe, I don't know what happened. Maybe you forgot. This is your chance. You can still get it.
Yeah, okay. Next up. This is exciting.
This is a revision, but this is a pretty big revision, so I'm going to mention it. Sometimes we just revise a product and change the silk screen or tweak it a little bit just to make it a little bit better. We don't talk about it, but this is a fairly big revision.
Yeah, so we squoze the Metro down into Metro Mini.
Yeah, we did that, but then we made the Metro Mini even better. So if you go to the big picture, Oh, this is the previous photo.
Oh, is it?
Yeah, that's okay. Maybe we don't have the... Can you go to the next one after this?
This one?
No, this is still the old photo. But it's okay. I'll also talk about it.
All right.
So go back one.
I got these too. I don't know.
No, I think maybe you grabbed the photos before they were updated.
Helpful. All right. I'm
Sorry.
not being helpful.
No, you're wonderful. You're wonderful.
Okay.
And it's okay.
Okay.
Not a big deal.
Well, let's talk about the past.
Let's talk about
what's different? This is the old one. What's the difference?
No, I just want to point out because see that there's this chip, not the Atmega 328, which is kind of like a diamond shape orientation. The one over here says FTDI. It was the FT231X USB to serial converter chip, which is a lovely chip, but we get the Scilab CP2104 chip nowadays, and we've been using it in the Huzzah, and we also got a breakout of it. And I don't want to say it's a better chip, but it's kind of a better chip.
Okay, live editing right here. Did it. Done.
Dude, I'd do it live. So you saw that we just swapped that in. Instead of the FT231, we now have the CP2104. The CP2104, it has slightly different driver requirements, but they're just as good. The CP21, it can go much faster. It does extremely high speeds. It can do weird speeds very well. It has drivers for every operating system. It's very well supported. I personally think it's a little more reliable than the FT231X, but most importantly, it's $1 cheaper. And because it's $1 cheaper, guess what we did?
What?
We lowered the price on the Metro Mini by $2.50. So you can now get a Metro Mini for even less, but it works just the same. All you have to make sure is just grab the drivers, we link to them, and as far as you can tell, all the LEDs work the same, works with their Arduino IDE. It's wonderful. It's as expensive. We also added in a 3.3 volt regulator. We had a little bit of extra space, so you get a better regulator now. It's all good. It's all better. It's the new Metro Mini. It's revised.
I see Scott said Scilabs does better FTDI than FTDI.
A little bit.
Yeah.
But basically, they gave us an excellent pricing on the chips, and given that they're otherwise equivalent, I would rather provide people good or better quality with a lower price.
Yeah.
Everyone wins.
All right, and that's what the new thing is. I'm like the John King magic wall guy here.
I know, you totally moved it around.
Next up. All right.
You get 2,104 electoral votes.
The star of the show tonight, besides you, lady, is this.
The star of the show today is a new FeatherWing. I know y'all loved all those FeatherWings. We had one FeatherWing a week for so many weeks. We took a little bit of a break, and we came back and did the Ethernet FeatherWing, and then took a little bit more of a break. Now we're back in action with the TFT FeatherWing. You know what's funny is now because we have so many more feathers, I have to make sure that whatever I make is compatible with all of them. It takes a little bit more effort. So this is a 2.4-inch 320 by 240 16-bit color display, and it works with any and all feathers. So whether you have the Feather 32U4 or the M0 or the Wicked Feather or the Feather Fauna or the ESP266 or maybe even the future ESP32, it'll work. This is a fully assembled FeatherWing. It's a little bit bigger than those FeatherWings, so the feather goes on the back, but you get all of the joy of the Adafruit ILI GFX 9341 GFX library, plug and play, and you get an SD card holder, and you get a touch screen, and you get an on-off switch because we had a little bit of space, and a reset switch. It's kind of like an all-in-one ready to go. And then since your Feather has built-in battery charging, you can make a little portable display, thank you, like on the overhead. It's just resetting every few seconds. But this is using the ESP8266 FeatherWing. Let's get that nice and zoomed in. You can kind of do it. Here you go. And then you have a battery attached to it, and then it's got the touch demo here, so you can touch screen. And the image is stored on an SD card, and then you can turn the whole thing off with the enable pin using this. Oh, I forgot to say, it also works with the Teensy 3 Feather, except for the on-off switch, because there's no enable pin on the Teensy, which maybe I'll revise. But for now, it does work with all feathers except for the on-off switch. Depending on the feather, some of them don't have an enable pin. But other than that, you can have a lovely little display. Turn it back on.
Beep.
And then let me get the other demo here. So we've got another demo here. Maybe I'll unplug this one. Plug this one in. What is this demo? Is this even running a demo? I don't remember.
You have so many demos.
This might be... Oh, you know what? I think this is a fresh ESP. Never mind. I forgot to program it. Well, let's pretend it was programmed. But it can do
snow.
It can. Yes, it's a drawing of snow. But yeah, you can have graphics, text, icons. There's like demos that you can have, like the weather display on your ESP 8266 or a touch interface or what have you.
Wi-Fi device. That's cool. Okay. And with that, Lady Ada. That was...
Yeah. What's nice is it just plugs right in.
Just plugs in.
Very easy, and then you even get another row of headers here, so you can plug this into like a breadboard or something if you want.
I like that all this stuff just works.
It really takes a little bit of effort, but it just works. Works with all the feathers, so very handy.
Okay. Don't forget the code is TFT Feather, 10% off on Adafruit store all the way up to 11:59 p.m. except for gift certificates, software, and Ada Box subscription. Lady Ada, we're going to do it. We're going to have some top secret. Everyone likes top secret.
Ooh.
Into the vault of Adafruit.
Jeez.
Okay, top secret this week. You have two things. One, you have a SAMD based Gemma-like thing. What?
Yeah.
What?
Well, here's the deal. I like the Gemma. You like the Gemma. I like the Gemma. We all like the Gemma. We invented the Gemma about 2 years ago. The Gemma is kind of a flora killer. It was basically something that would be simpler and easier and less expensive than a Flora. The Flora, we've been able to get the price down quite a bit. By negotiating and increasing our yields and manufacturing and all that good stuff. But I was talking today with the MicroPython folks on our team and saying, like, hey, the Gemma uses the ATtiny85, which is a cute processor. It's very inexpensive, but it has the issue that it bit bangs USB. And because it's bit banging USB, every time there's a new Mac OS, there's just like issues. And it doesn't always work very well with USB 3 ports, and it's a little bit frustrating sometimes because the Gemma is wonderful, but depending on your USB driver host software, it can be a little bit flaky. You might have to go through a hub.
Yeah.
It's solvable, but it's not great. So what I thought is, since we're doing MicroPython, And the MicroPython has about as much power as the ATtiny85 using Arduino. What if we took the ATSAMD 21E18, which is a smaller pin version, same flash, same RAM, but just smaller chip, fewer pins, and put that in a Gemma. It's a 5x5 millimeter QFN compared to the ATtiny85, which is a 4x4 QFN, but you know what? Fits.
Yeah.
And it doesn't need the inline resistors or a 1.5 key pull-up, so I dropped 3 resistors there. And then we wanted to, instead of having a single LED, we actually put a dot star LED. So the LED all the way to this left above the button, kind of next to the A0, that 6-pin thing, that's actually a full color dot star LED that comes in a 2 millimeter by 2 millimeter package.
So tinier.
Very small, but it's you push
cool.
SPI to it, and it just has any color. So that can be a nice indicator. So instead of having a red LED on pin 13, we're like, let's just put in a full color and NeoPixel, basically, as far as people can tell. Still get the on-off switch, still get the power switching micro USB. You can use it with Arduino, because Arduino supports
I was going to say, that's what I like about this. You
SAMD21.
could start with something like MicroPython, later on turn it into an Arduino-like thing, but no matter what, when you decide what you want to do, you can choose the bootloader that you want to put on it, and when it's in MicroPython mode, it shows up as a USB drive. You could just edit a Python file right there.
Yeah, maybe it would be a little MicroPython, but basically it's like
wearable MicroPython. That's cool.
Wearable, very low cost, very small, very simple. Working with Atmel to get good pricing.
Yeah.
Right now you can buy the ATSAM D21 E18 or whatever, E18 for like $250, but if we can get them to give it to us for like maybe half the price, that'd be really cool. We would have something about the same price as the Gemma, but 256K flash, 32K of RAM, can run Python, can do Arduino. It still only has 3 pins, but like you get a DAG, you get ADC, you can still do quite a bit. And a lot of people's beginner projects, they don't need to have 30 pins. They just want to get alligator clips, connect it, sense something, print it out, maybe play an audio clip, control some NeoPixels. Very
good
basic
for workshops
projects.
and more,
Yeah.
Okay. And then the other thing in the secret vault, you wanted to show the ESP 32 feather, right?
We had this last week, the little printout of the ESP32 feather
real.
design.
This is prototype, so we do red. It's not going to be red.
Yeah, the final design. This is a prototype just to let me know that, hey, this is not a final design. And I fit it, and it solders in. And I got it to boot. I haven't actually had time to like try out really programming it. Things have going on. I don't know, excitement in the world. But I'll have some time tonight. And then this also has that CP2104 you know and love. A slightly nicer power switcher, USB LiPo charger, LiPo board, and then 2 LEDs charging an indicator. And then all the pins get used, which is actually kind of neat. One of the LED pins is a pin here, and then we have special pins that we don't want to toggle because they're used for like the bootstrapping. So we left those unconnected, but we have enough pins for the feather connector here. So that'll be nice. And then of course I have to test it with every FeatherWing, but that's a good way to tell. Does SPI work? Does I2C work? GPIO work? You'll know real fast if it works with all the FeatherWings. So that's it's not out yet.
Okay.
Red. Blood red.
Back in the vault. Get back in there, vault. Get back in there. Okay. We're going to do questions now.
Yeah.
Post your questions in the chat. One of the questions that someone had before with the sensor that you showed, can it do down to 4K?
I don't remember look. If you Wikipedia for PT100, it has like all the specifications and details and algorithms. Again, we're gonna have an amplifier. It's the Max 31865, not the 56, and that will be our thermocouple amplifier. But we haven't finished it up yet. When we're finished, it'll be kind of an SPI ready. It's a very good resistor sensor that has a reference, a 0.1% reference, and so you can use that to measure the platinum sensor. Or you can build your own. There's designs for RTD sensor.
If someone has a motor breakout board, could they use that with a Gemma or a Flora or a Feather? How would they use it?
I would use it with the Flora, or basically a Feather is the best because it's breadboard compatible. If you have a breakout, that's probably the best thing. The Flora and the Gemma, they're really meant for wearables.
Okay. I've been using Arduinos and Raspberry Pis for a while. I'd like to get an STM32 board, which is a good one to start with for a newbie.
You know, there's low-cost ones. I don't know of a offhand one. We don't really carry STM32. The Wicked Feather is STM32 F3 based, but I think, you can get a board for like $10. Like, pick one up. Maybe an F103. That's a very popular version of the STM that I see around.
Okay, international AdaBox. Well, that's something we're working on for subscriptions, because with subscriptions it's a little tough because the shipping is already taken care of.
Yes,
so
do you have two rates?
We're working with partners, but look at the AdaBox, the standalone one.
Yep.
Next up, is assembly still worth learning? Yes.
I think so. I think it's worth learning. I mean, I would learn a risky assembler like MIPS or like AVR or ARM Cortex. Handy. A lot of ARM Cortex based chips. If you learn that chipset, you'll be able to use it on a lot of different platforms.
Right now, what's the process of submitting a product idea? Well, right now, if you submit it to support@adafruit.com, we'll take a look at it. The team checks it out. We have so many products that we're working on that we generally don't take on outside new products. If it's finished and it's done and you have documentation and you can point to it and show us, let us know.
We'll always take a look.
Yeah, we'll always take a look. One of the things that we like to make sure that we do is, if we're doing an Adafruit product, it really works well when we focus on the documentation, the videos, and more. So when you send in a product, if it's more cooked and you're selling it, or if it's on Tindy, you send a link to it. That's a lot easier for us. But definitely, no matter what, do documentation. That's what we look for, because that means you've thought about how people are going to use it. Okay. Next up. Have you thought about, where can I order more than one Pi Zero? I think it's limit one everywhere.
It's limit one everywhere.
Have you thought about using the Atmega 328 PB?
I've thought about it, but without having an Arduino core, it's a lot of work, and I don't know how many people really want it.
Okay.
Sorry.
Is there a way to use multiple processors and have them communicate via I2C?
Yes, but not well.
Okay. Lady Ada, are you going to do a Feather adapter for THC 3.5, 3.6? Just got one and having fun making synths with it.
Probably not, because it's huge and it wouldn't really fit on a Feather. I mean, we'll see. But right now, the 3.2 is still by far the most popular Teensy. So I might revise that Teensy FeatherWing to change the power manager so it does enable and is a little bit friendlier, rather than trying to adapt this huge thing. Okay.
Do we have any SAMD tutorials about direct GPIO use, like using port X with Atmegas? I don't think so.
We do
Search
not.
the
We
system,
have a
just to
tutorial
make
for
sure.
Circoms. We don't have one for GPIO, but it's not too difficult. The only thing is you don't gain anything. It's not going to be much faster, but you can check. I think our NeoPixel code probably does direct pin access, but it's you're going to go through the ASF wrapper. Yeah. You don't tend to actually write directly. Well, you do like to register directly, but it's a little bit different than the AVR style. Okay. And I don't remember, sometimes for some peripherals with the SAMD, you have to kind of do this peripheral syncing. I don't remember for the GPIO peripheral. You have to. Probably not.
Chad says he's putting together his first Raspberry Pi 3 and touchscreen while watching. One of the things that I noticed is people like to make electronics where they're watching electronics. Kind of
yeah, I know. You want to get multi-sensory electronics, just hearing electronics.
Yeah, I think when you go to a coffee shop to work. Let's see. How about the AtSAMD 11? What do you think about that?
The AtSAMD 11 is nice, but the price difference between that and the SAMD is not that great, and I want more flash and RAM. I'll pay a little bit more for that flash and RAM on the SAMD 21, and also again, you get that full plethora of Arduino compatibility. The SAMD 11, I have a couple. You can't use Arduino with it. I've adapted it. It's there's just not enough RAM. You really need a ton of RAM, a ton of flash.
This is I'm not sure the answer to this because everything is kind of new. Could the ESP Room 32 be used as some type of proxy such as FTP?
Who knows?
Yeah.
Maybe.
Next up, can the Raspberry Pi 3 both have a D-pad and analog stick for Game Girl?
You can, but you'd have to have something that reads that analog stick. And you'd have to design it in.
Okay. And how can I troubleshoot an opto-isolated doorbell sensor that seems to be getting the trigger by my light switches?
Well, it could be noise, or it could be optical. right? It sounds like you're saying lights, but I don't, if it's a sealed opto-isolator, like a 6N138 type thing, you're not going to have any light. Light cannot get into it. It's fully epoxied. Could be that there's just some jitter in the noise, or maybe when you switch the light, you get a spike high or low in your power supply, and that's triggering it.
Okay, 2 more questions. Is it possible to get a motor breakout board working with Pi 0?
I would use our motor hat. That'll work.
All right, I'll squeeze in a couple more questions. Someone's going to build a speedometer for their dirt bike. What type of sensor should they use? Can you use an inductive sensor to measure water level?
I've never used an inductive sensor for water level. Maybe. For a speedometer, you'll want to use whatever is on your dirt bike. There is probably some hub sensor that's used that you want to get into. There'll probably be a magnetic sensor that you can tap into an optical sensor. That's probably your bet. Okay. See if there's one that you can get that's done for you, because it'll be spinning on very fast. You want to make sure it's well designed.
And Frank says, as 2 grandkids, would love to help them get into electronics. Do you recommend an easy kit for a 12 to 15-year-old to start with? Well, it depends. If they're doing any type of programming classes in school or whatever, there's options like an Arduino. There's also things like the Kano kit or the PyTop, where it's more of putting it together and then like doing some coding. And then there's very basic stuff if they've never been exposed to stuff like little bits, or even if they want to solder, they could do a very simple thing.
There's a lot of options.
A lot of options, but I would check out the Young Engineers section on our site. We have lots of stuff there. Okay.
Whatever they are interested in.
Those are the questions tonight, ladies.
Okay, yay.
Zoom. Okay.
Go team us.
All right. It's trivia question time.
It's time to give away something.
What are the rules, Lady Ada?
Rules are, if you've won something before, you can't win again. Only one winner per my lifetime. The prize will be given to whoever answers the question the way Phil wants it answered in the chats that he's looking at.
A lot of pressure on me.
It's a lot of pressure on you, sorry.
Yeah.
And then the prize tonight is a TFT FeatherWing.
Ooh.
Great. If you already have a feather, add it on, and now you're glowing.
Okay.
As they say.
Are you ready?
I'm ready.
For the question?
Yes.
This is going to be a fun one.
I'm
pretty easy.
Ready.
Okay.
Go for it.
What group of folks are we celebrating this month on the Adafruit website in the blog? It is blank blank Heritage Month on the Adafruit site. We had a couple from the time travel section, so it's pretty easy, and this is a good thing for people to know because every month has a different type of celebration. We do that on our site. What group of folks? Type it in the chat.
Okay.
42 is not the answer, but I'm glad everyone always puts that in there. Let's see. RD2222 in Twitch. Congratulations, Native American Heritage Month. You got it. All you had to do is watch the show just a little bit.
That's how easy. It's both a cool Star Wars reference and like a type of NPN transistor.
Yeah, so email support@adafruit.com, and what are you going to send them?
They're going to get a PID 3315.
Yeah, it was that easy. Look how easy that was. That's what we were doing.
Just tell them 3315.
Yeah.
You will get your own TFT FeatherWing.
Yeah.
Wow.
Okay.
Honestly, you could use it with other devices. You just plug wires in or solder wires. You can use it with other stuff, but it works great with feathers.
Yeah.
And I try it tonight with maybe this ESP32 feather. I'd like to get this up and running, and then maybe.
Okay.
Wouldn't that be cool?
Yes.
Plug it like that. Bam.
Very
nice.
Okay. Thank you so much, everyone. If you didn't win, you can still use a code. It's like winning. Yay.
It's like winning.
It is. TFT Feather, 10% off in the Adafruit store. And thank you, everyone, all of our remote folks, our internal folks, everyone who makes Adafruit a great place.
Yay.
Thank you for making this possible. And as we embark upon 2017, let's all promise to make cool things together. Because I think.
And MicroPython.
I think that.
And name the snake.
Well, I think that, when I was at Make and you've been in all of the Maker fairs with me, one of the things I notice is all people like to make something. And it's an excellent way to get to know people and to bring people together. And it doesn't matter who you are, your background, your skill set, where you live, what part of the world you are, whatever it is, making things is the universal language.
It's fun.
And I think if everyone just stopped and thought, instead of how can I argue with someone, or how can I figure out how I'm different than someone, is like, what could we make together? And I think that that's something that we need a little bit more of. So, you know, spend some time, think about something you can make with someone. Hacker spaces, tutorials online, video shows like this. It's a really amazing time with technology, but it shouldn't be used to keep people away. It should be used to be a uniter.
More making, less hating.
Yeah. So anyways, I know it's been a interesting, exciting, tough week for everyone who's
I'm glad it's almost over.
Who's lived through the U.S. election cycle. But thanks for making this a great place, everyone. And you know, we're here. We're going to keep doing this. Keep doing open source.
We're still here. We're not going anywhere.
We're going to keep making stuff in the U.S. And we very much appreciate your support. And thanks for purchasing kits and more. So, all right, we're going to fuel you up, and then we're going to do some more electronics.
You're probably going to do some MicroPython tonight.
I have to, and I want to. I need to. I also have to pet a cat. Speaking of, here's a picture of a cat. We'll see everyone next week. Here is your moment of Zener. Bye, everybody.